Hey everybody, we are going to finish out this remote learning with some basic trig identities. Remember we talked about the unit circle having a radius of 1. And if we drop down a line, we can see the height easily, and that's x. And then of course the horizontal distance is y with this point x, y. And you guys already talked about why that is the same thing as cosine comma sine. And this might have come up already, but I can't remember if it did or not. So here's tangent. We know from SOHCAHTOA that tangent is opposite over adjacent. I'm going to add a little theta right there. So opposite over adjacent in this case would be y over x. But we just established, or you guys established last week, that y is the same thing as sine. And x is the same thing as cosine. Sorry about that. Okay, so that means that tangent is equal to sine over cosine. That is going to be an important identity that you're going to use a lot, and you'll definitely use it a lot in pre-cal next year. And then there's a couple more that you need to know. Since I'm talking about tangent, let's go ahead and talk about cotangent. Cotangent is what we would call a reciprocal identity. So it is equal to 1 over tangent. So these are just kind of like some definitions of things. Cotangent is 1 over tangent. If you were to do 1 divided by something, remember how when you divide by a fraction, you can multiply its reciprocal? So doing 1 over tangent, and tangent's the same thing as sine over cosine, that's actually the same thing as multiplying the reciprocal. So I have 1 over sine over cosine. And if I multiply the reciprocal, I'm going to have 1 times cosine over sine. Well, of course, 1 times cosine over sine is just cosine over sine. So there's kind of 2 things that go with cotangent. There's the fact that cotangent equals 1 over tangent, which means it's just the reciprocal of tangent. Also, cotangent can be defined as cosine over sine. And all of those are the same thing. They're identities. They're just different ways of looking at it. Okay, so just like tangent has a reciprocal identity, which is cotangent, sine and cosine do as well. So there's one called cosecant. I'm going to spell it out for you. But the abbreviation for it is CSC. So the cosecant of theta is defined as 1 over sine. It's weird, I know, you would think cosecant would go with cosine, but it doesn't. Cosecant goes with sine. So you could just take whatever sine is and reciprocate it, flip it over, and that would be cosecant. And then the last one is secant, and its abbreviation is SEC. And secant is the reciprocal of cosine. I'm being really careful to say reciprocal and not inverse or opposite. Opposite kind of assumes that you're switching a positive and a negative, and inverse is, you guys have already learned, the inverse of cosine is the cosine with a little -1, and that's when you find an angle instead of a side. So this is not the inverse, this is not the opposite, it is the reciprocal. So these are the reciprocal identities, those 3. So we're going to use those to solve some basic problems. Let's start with our unit circle. I went ahead and inserted a filled out version of the unit circle to make our life a little bit easier. So I'm just going to kind of start picking some problems. Let's suppose that I want to find the tangent of 5 pi over 6. So I would go over to my unit circle, find 5 pi over 6, there it is. I see that the point is square root of 3 over 2 comma 1/2. Now remember that tangent is sine over cosine, which is also the same thing as y over x. And so the sine is going to be 1/2, and the cosine is going to be square root of 3 over 2. And technically that's the answer, but that looks super ugly. So remember, when you are dividing a fraction, you can multiply its reciprocal. I left the 1/2 alone, and then I reciprocated the square root of 3 over 2. And when I multiply across, you can go ahead and divide out the 2's if you want to. You end up with 1 over the square root of 3. Please make sure the square root of 3 doesn't just magically appear on top. It is in the denominator. Okay, again, that is actually technically the right answer, but it is not proper because it has a square root in the bottom. So I'm going to rationalize it with square root of 3 over square root of 3. Remember, that's like me multiplying by a big fat 1. 1 times the square root of 3 is just square root of 3. Square root of 3 times the square root of 3 is 3. So the tangent of 5 pi over 6 is square root of 3 over 3. Now the thing is, you're going to start seeing these numbers repeating themselves over and over and over, because that is, I mean, the unit circle repeats itself over and over, so it makes sense that you would end up with the same answers here too. Let's do a cotangent. I'm thinking the cotangent of 7 pi over 6. Ooh, you know what? I just realized something. I just noticed a mistake. If I go back, I'm missing a negative sign, aren't I? 5 pi over 6 should have a negative on the square root of 3 over 2. That should be a negative right there. So that should be a negative, so that should be a negative, so this should be a negative. So the final answer should have been negative. I realized that when I looked at 7 pi over 6. So if I wanted to do the cotangent of 7 pi over 6, that's down here. Cotangent is the reciprocal of tangent. So instead of being sine over cosine, it is cosine over sine. We just talked about that. So cosine is negative square root of 3 over 2. Sine is negative 1 over 2. And again, I'm getting that from my point over here. So I'm going to simplify that down here. I'm going to leave the negative square root of 3 over 2 alone, and then multiply the negative 2 over 1, multiply the reciprocal. This one's prettier. 2's cancel out. Negative times a negative is a positive, and you're just left with square root of 3 over 1, but that's just the same thing as saying a square root of 3. Okay, let's move on to a secant and a cosecant problem. I'm going to go down here on the bottom. So let's suppose that I wanted to do the cosecant of 2 pi over 3. So first thing is I go over to 2 pi over 3 and take a look at the y value, because cosecant is the reciprocal of sine, and sine is the same thing as the y value on the unit circle. So it's technically 1 over sine. You could actually skip this step if you want to. I just wanted to show that 1 over sine is the same thing as like just reciprocating the sine fraction. So I have 2 over the square root of 3. That's technically the answer, but I need to rationalize it again. So I'm going to multiply by the square root of 3 on the top and bottom. And there it is. That's the cosecant of 2 pi over 3. Let's do a secant problem, except this time let's maybe do a bigger angle. No, let's do a negative angle. Then we can do a bigger angle. So how about the secant? Sometimes they use parentheses, sometimes they don't. It's not really a big deal. Let's say negative 5 pi over 4. Okay, a couple of ways we can do this. I'm going to look up here real quick. You can look at where positive 5 pi over 4 is and then just kind of like flip it over the x-axis. I kind of like to think of it in terms of position. So there is positive 5 pi over 4. If I go that same angle, or that same kind of distance, if you will, but start with that positive x-axis and go negative, go clockwise, I'm going to land there. So you can see how the blue and the red are like the same amount of angle, but one started going counterclockwise and one started going clockwise. So negative 5 pi over 4 lands on 3 pi over 4. The term for that is coterminal angles. They land in the same spot. They terminate in the same spot. Secant is the reciprocal of cosine, and the cosine of negative 5 pi over 4, from looking at that line I just drew, is negative square root of 2 over 2. So secant is going to be 1 over that, which means I can do the reciprocal. You could put the negative on the top or the bottom, doesn't really matter. And then I'm going to multiply the square root of 2 on the top and bottom. And notice that 2 divided by negative 2 is going to be negative 1. And square root of 2 is just going to stay. So the secant of negative 5 pi over 4 is negative 2. Alright, I just want to talk about one last thing, just in case you got an angle that looked kind of huge or weird. I'm going to kind of address like two strange things here. Let's suppose that I wanted you to find the secant of 11 pi over 2. Okay, I think this came up really briefly last week, but only ever so briefly. 11 pi over 2 doesn't immediately show up on the unit circle because that is a lot bigger than 2 pi. It's basically gone around multiple times. So some people like to just count it out. I kind of like to think about it in terms of 2 pi's. So one time around is 2 pi. 2 pi is going to be the same thing as 4 pi over 2. If I multiply the top and bottom by 2, I get 4 pi over 2. So one time all around is 4 pi over 2. 2 times all the way around is going to be 8 pi over 2. And if I want to get to 11, I need to go 3 more. So I'm going to go 1, 2, 3. So I'm going to land right there. So that is coterminal with 3 pi over 2. Another way to do it is just subtract, like realize, like, okay, that is too big. I need to subtract 2 pi. Well, if you're going to subtract something that's a fraction, you need to make it have common denominators. So you're like, okay, I need to do 11 pi over 2 minus 4 pi over 2. And when you do that, you get 7 pi over 2. And then you realize 7 pi over 2 is still too big. And so you subtract 4 pi over 2 again. And this time you get 3 pi over 2. And so you're like, oh, okay, 3 pi over 2. That's on the unit circle. I know what that means. Okay. Well, the point right here at 3 pi over 2 is 0, negative 1. If I want the secant of 3 pi over 2, or the secant of 11 pi over 2, so they're laying in the same place, that is 1 over cosine. Well, cosine in this case is 0, and 1 divided by 0 is undefined. So don't be surprised, now that you guys know these reciprocal identities, you are definitely going to get some answers that are 0, and you're definitely going to get some answers that are undefined. So there's a little short practice for you guys to try today. I'd love for you to try it out, and then there's also an answer video below if you need help.